Chapter 11, Section 5 is on graphing tangent functions. This will be our last section in this chapter. In the past, we've graphed sine and cosine. Today, we'll graph tangent. Here, I've got a unit circle with points at 1, 0, 0, 1, negative 1, 0, 0, negative 1. So it's a circle with a radius of 1 unit. But before we talk about graphing on the unit circle, let's imagine this fairly common movie scenario where at the end of some bad CGI sci-fi type movie like a Ninja Turtles or Marvel movie, there's a sky laser, right? They all have these, a laser pointing up into the sky going like this. And if it ever gets to the top or gets far enough away, it summons the bad guys or opens a portal or blows something up or something. What we're going to do is we're going to establish 100 feet away a counter laser. And what happens is if the counter laser hits the bad guy laser, they cancel each other and make a really cool explosion of some sort, I'm sure. And this counter laser is going to be set up 100 feet away and pointed in the same direction. So this distance right here is 100 feet. Well, the question becomes, depending on what angle this counter laser is firing at, how high will these two lasers meet? Well, let's say to start, this is at 45 degrees, okay? Which this actually is drawn to be 45 degrees right now. If this angle is 45 degrees, this is a right triangle. This side over here is also going to be 100 feet because this would be an isosceles right triangle. Pretty cool. But let's say that this counter laser is going to start changing its angle. Let's say it's going to get steeper and shoot up like this. Let's say this is, 60 degrees. I'm actually not trying to pick all unit circle measures. We'll say 60 for now. Well, this laser shooting up like this laser shooting up like this, they're going to meet right about here. Okay, well, how high is that? What is this height here spanning all of that? We would find that with tangent. The tangent of 60 degrees equals the opposite over the adjacent, but we know that the opposite we're calling height, and the adjacent is 100. So 100 times the tangent of 60 gives us this height. Let's calculate what that is real quick. We're doing this in degrees. So my calculator's in degrees. If I do 100 times the tangent of 60, 173 feet. And then let's think about what happens as this gets really, really close to 90 degrees. Like say this angle here is shooting up like this. Let's say this is 85 degrees. It looks like it's actually more like 88 or 89. Let's say 85. It's going to be the same thing. 100 times the tangent of 85 equals h. (1,143 feet). And this value can just keep on increasing and increasing and increasing until we're at exactly 90 degrees. Let me show you 89.9. The tangent of 89.9 times 100 is 57,300. And as this angle gets bigger and bigger, so I'll go for the last time 89.99999. Oh, it's just insanely high. I can make this number as high as I want by adding just a little bit more of a degree while I stay beneath 90. However, if this thing hits exactly 90, these two lines aren't ever going to touch each other, of course, because they're parallel, and it wouldn't make any sense. That's why the tangent of 90 is undefined. You can't have an opposite and an adjacent if the tangent angle is 90. We had these 100 feet away. On the unit circle, they're 1 feet away. Tangent is the ratio of doing the opposite over the adjacent. And what happens is, as this gets really, really close to 90 degrees, the ratio can get incredibly high. And as it gets really, really close to negative 90 degrees, it gets incredibly high but negative. And here, at 0, it's actually just 0, right? The tangent of 0 would be opposite over adjacent, which we also know is sine over cosine. It's just the y value over the x value. And if it's 0 over 1, that's just 0. That's no problem. Okay, so the tangent of 0 is just 0. But the tangent of 90 is going to be undefined because it's 1 over 0. Sine over cosine. You can't have that. So the tangent function actually stretches from negative 90 to 90. And in between that, every single number is possible. You can get as large as you want at 89.9999999, or as a large negative as you want at negative 89.999. That's the idea of graphing a tangent function. So here's our list of formulas for how to graph this tangent function. The parent function is y equals tangent theta. The a and the b value will change the vertical stretching with the a value, or the period with the b value. We're not going to play with horizontal translations, phase shifts, h and k, that kind of thing. The period is found by doing 180 over b instead of 360 over b, like with sine and cosine, or pi over b if you're in radians. That's because tangent goes from negative 90 to positive 90, and in that period, you accomplish a whole cycle that goes from basically negative infinity to positive infinity with everything in between. So the period of tangent is 180 over b, not 360 over b. So to find the scale, to count by on the x-axis, still just divide that by 4. The scale is always the period divided by 4. I'll talk about these asymptotes in just a second. But let's start graphing. I'm going to make a table, and in this table, plug in easy values that I know. We're graphing the parent function, f of theta equals tangent of theta. Yeah, so we're going to have theta of 0 degrees, 90 degrees, negative 90 degrees, and also 45 and negative 45. And I'm going to leave room to also do like 89.9, but give me a second on that. We know the tangent of 0 is 0, okay? Tangent sine over cosine. So if we're at 0 degrees, that's 0 divided by 1, which is 0. So we have 0, 0. I'll scale this out real quick. I'm going to count by 45s, which makes every other dot, left and right, be counting by 2. 2 dots is 40. 2 dots makes 90, so 1 dot's 45. We have the point 0, 0. We also know that at 45 degrees, the ratio is 1, because it's sine over cosine, and at 45 degrees, that's root 2 over 2, comma, root 2 over 2. Something divided by itself is 1. So we have the point 45, 1. We also have negative 45, negative 1. At 90 degrees, we are undefined. There's an asymptote right here. At negative 90 degrees, we are also undefined. So there's an asymptote here. And in between all this, we have this sort of curve. This is one cycle of the tangent function. Remember, if I were to do like 89.9, I'll do negative 89.99. That's something really big, but also negative. That's why the graph points down forever as we go to the left. It could reach any value that it wanted to. In the same way, it points up to the right forever because we can get as big as we want to. So the range of this function is all real numbers. It covers everything we could want to cover. The domain is restricted by asymptotes, but now this can keep cycling around. We just covered from negative 90 to 90. But if we go from like 90 to 270, okay, if I do this half of the circle, it follows the same exact pattern. At 180, we have 0. At 135 would be negative 1, and 225 would be positive 1, and 270, another asymptote. And this cycle is going to keep repeating. This is a tangent function. It looks pretty nutty, but there it is. Okay, let's talk about the domain and the asymptotes. This has asymptotes at 90, and then again at 270, and at negative 90 and negative 270. Each asymptote has a distance apart of 1 period. The period is 180. So to find an asymptote, but the way you do this is you first just find 1. Okay, so we know there's an asymptote right here at 90. So I'm going to say the asymptotes are going to be such that x is in the set of 90 plus whatever my period is, and that's what I'm saying here. It's 90 over b. In this case, b is 1. So whatever the period is times n. Period times n. I wrote k here, but I actually want that to be an n. So 90 plus my period times n. And n just stands for any integer. This double z here that I just wrote hideously represents any integer. Integers are positive or negative whole numbers, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, etc. So it could be 90, or it could be 90 plus a 180, or it could be 90 plus two 180s, or 90 minus one 180, or minus two 180s. It's always going to be a change of 180 because 180 is the period, and we don't know how many periods we're stepping. So this is how you'd find all the asymptotes. That also means that our domain is everything except the asymptotes. So the domain is the same exact thing, only with a slash through it. X is not in the set 90 plus 180n, where n is any integer. Okay, that's your parent function. I'll do another one, and I hope that with the second example we can just sort of see the patterns. It turns out all you have to do is find a period, find a scale, and count to 4 a couple times. So let's do that. 3 tan 2 theta. The a value is 3, and the b value is 2. So that means that the period, let's do this one in radians and not degrees, okay? The period is going to be pi over b, which is pi over 2. My scale is just the period divided by 4, so it's going to be pi over 8. So I'm going to count by pi over 8s on the x-axis. So this would be 1 pi over 8, this would be 2 pi over 8s, 3 pi over 8s, 4 pi over 8s, which is just pi over 2, 5 pi over 8, 6 pi over 8 is 3 pi over 2, 3 pi over 4. And this way, negative pi over 4, negative 2 pi over 4, which is just pi over 2, and negative 3 pi over 4. My y values have to go as high as 3, so if I just count by 1s, that'll happen. So here's y, here's my theta axis. Now I said all you have to do is count to 4, and that's true, but it's maybe easier if you think about it as counting to 2 twice. If I'd go 2 steps to the left and 2 steps to the right, 2 steps left and 2 steps right, those are my first two set of asymptotes. So at negative pi over 4 and at pi over 4, I have asymptotes. In between, at this, we know it starts at 0, 0. And then at pi over 8, I'm going to get out a 3 and a negative 3. That's coming from this value right here. That is my step to the right and step to the left from the middle. So I'm going to have a point here at positive 3 and a point here at negative 3 because of the a value of 3. In between, I connect the dots. The tangent looks like that. Then I count 4 more to the left, so I was here for an asymptote. I go 1, 2, 3, 4. There'll be another cycle here. And 1, 2, 3, 4. Here's a tangent asymptote. So another cycle is here. The domain of this function would be, well, it's easiest first to do the asymptotes. The asymptotes of this function are going to be that x is in the set, and again, I just pick one to start. I see there's an asymptote at pi over 4. So I just write down pi over 4. Then I'm going to add the period, and the period of this was pi over 2, and just do that times n, where n stands for any integer. Those are your asymptotes. That means that my domain, I could just change the word asymptote to domain, and it's all those things, everything but the asymptotes. X is not in that set as my domain. Okay, last example. Y equals negative 4 times the tangent of 3x. This is going to be very similar to the last one, only it's negative. That means instead of the graphs going up as you go to the right, the graphs are going to go down as we go to the right. Everything's been reflected over the x-axis, so it's going to look like this. Let's do this one in degrees. So the period is going to be 180 over b, which is 180 over 3, which is 60. That means that my scale is going to be 15. Your scale is your period divided by 4. So I'm counting by 15s. Here's a 30, here's a 60, here's a 90. And that covers it. 2 steps to the right is an asymptote. 2 steps to the left is an asymptote. In between I've got a 0, a -3, and a +3. There's a tangent cycle. Let's do it again. So I get my next set of asymptotes, and in the middle of them is the 0. To the right side was down 3, to the left side was up 3. Here's the next tangent cycle. There's 3 cycles, which you should always be graphing on homework. 3 cycles of this tangent function. Take a second and try and figure out where the asymptotes are, what's the domain, and what's the range. The first asymptote I'm going to pick is right here at 30 degrees. This one right here at 30 degrees. So there's an asymptote of x in this set of 30 degrees plus whatever my period is, which was 60. So 30 plus 60n, where n is any integer. This is supposed to be a z with a second little thickness to it. That capital Z stands for integer. So the domain is everything except 30 plus 60n. And the range is always, with tangent, going to be all real numbers. Okay, let me graph this on the calculator so you can see how that works. I'm going to make sure that my calculator is in degrees, which it is. When I press y equals -4 times the tangent of 3x. When I press graph, I have to first make sure that the window of my graph looks like the window of this graph. So I'm going to have my x's go from -90 to 90. And have them count by 15s, because I was counting by 15s, that was my scale. My y's can go from -3 to 3. And it looks like 3 straight lines. If I have the y's go up higher, you can see the curve a little bit better. Let's have the y's go from like -10 to 10. There's that curve. Yeah, they're really supposed to be pretty wavy. Make them look like these waves. Beautiful. Okay, a tangent function has a range of all real numbers. The period of the tangent function is 180 over b, which is the same as pi over b. Their asymptotes located at 90 degrees plus the 180k, but those can be changed by the period. So those could both be divided by b. Again, I said k, but I'm using n, not k. If the b value is present, then both these would be divided by b. Find your scale, and from the origin, take 2 steps left and right to find the asymptotes. Nice work in this chapter, everybody. We've got one. We did it. We got through another math video. Thanks for watching. Here I'm going to play with the perspective on these shapes while I talk to you. Please subscribe to the videos, like the videos. Okay, start this thing over. You did it. You got through the video. Thanks for watching. I'm going to play with the perspective of these shapes, which is always pointing towards that center while I talk to you about things. Please subscribe to the video, the channel really. Please like it if you found it helpful. If you want to share it with friends and say, hey, this guy's not the worst, that's an option too. You can always take your video quiz if you're in my class. And comment down below. See you next time.